Hello and welcome to my presentation. My name is Dimitri. I'm a data architect at IBA Group with over a decade-long experience of building data integration solutions in various on-premises and cloud environments. Today, I will be introducing you to our in-house ETL tool called Visual Flow. Our data integration department has a background of 15 years of using traditional ETL tools such as IBM DataStage and Pentaho. And some time ago, we started delving into the big data territory, which led us to the idea of creating a tool that would apply our visual ETL experience to Apache Spark development. So what is Visual Flow? Visual Flow is a cloud-native ETL tool with a graphical user interface. It combines the best features of Kubernetes, Spark, and Argo workflows such as portability, flexibility, and multi-cloud compatibility, development efficiency, high availability, performance and fault tolerance, low cost, and open source code. Why should you consider Visual Flow for your ETL project? Visual Flow is an open source tool based on industry standard components. It can be deployed anywhere from your own laptop to a private cloud. It is rather easy to deploy, and even more so thanks to our comprehensive installation guide for AWS. Once deployed, you are only a few minutes away from creating your first ETL jobs. The learning curve is as short as they come. The drag-and-drop GUI is up-to-date and intuitive. The designer palette is large and keeps growing every month, supporting more and more popular transformations and connectors. For the transformations that are not currently supported by Visual Flow, it is possible to spin up a custom container within your pipelines, so you can control all your processing from the same UI. Your pipelines can now be scheduled in Visual Flow GUI using a simple and intuitive scheduler form. Last but not least, the development team keeps an eye out for our users' suggestions and concerns, continually updating their backlog to meet the most popular demands. Among such demands are the support of streaming, software as a service implementation for leading cloud service providers, extensive code change history, and multi-language support, and finally, embedded version control. So the Visual Flow project was started in early 2020 by a group of 6 developers, some of whom had previously worked in a large-scale data engineering project utilizing the same core tools that ended up constituting Visual Flow. Their goal was to create a solution that could help do their routine work easier, faster, with less mistakes and less people involved. At that time, other Visual Spark ETL tools had already been emerging on the market for a while, but they seemed to always be either costly or too tightly integrated with their proprietary platforms, thus requiring too much of a paradigm shift for the project. Our developers saw Visual Flow as a lightweight, easy-to-get, open-source solution that would nicely complement an already existing cloud or on-premises environment with little to no change in the infrastructure. With their ETL background, the developers knew well that switching from traditional ETL tools to Spark ETL may be harsh. While offering great flexibility, scalability, and unlimited parallelism, both Spark and Kubernetes demand significant programming, deployment, and configuration skills. Before one can dive into creating and running their first Spark ETL jobs, there's a need to know Python or Scala or Java, a build tool such as SBT or Maven, a workflow orchestration tool such as Apache Workflow, and let's be real, those instruments have a rather long learning curve. Traditional ETL tools, on the other hand, do not require knowledge of a programming language. Most of the designer palette is self-explanatory, and the build and deployment processes are hassle-free. In addition, they come with built-in monitoring, alerting, and error handling tools. With that traditional ETL mindset, Visual Flow was created. So how can I use Visual Flow in my project? In a modern data-centered cloud infrastructure, Visual Flow can be used to automate ETL tasks in a variety of scenarios, such as transferring data from transactional data sources and flat files from network file systems to the data lake, transforming and cleansing data within the data lake, transferring data from the data lake to the data warehouse, and transforming data within the data warehouse to fulfill the needs of the data analytics tools. To illustrate the benefits of using Visual Flow for accelerated ETL development, we carried out an experiment during which the same functionality was implemented manually in Scala and using Visual Flow. A simple ETL job that extracts data out of one S3 bucket, applies grouping and filtering, and records the result to another S3 bucket. That's really a basic ETL job, but such basic jobs constitute over 50% of a typical integration project. The manual implementation required a whole bunch of tools: Scala, Scala IDE, Apache Spark, Scala Test, Airflow, Maven, Jenkins, whereas Visual Flow already included everything you need. It took us only 15 minutes to build our ETL job in Visual Flow, and a whopping 2 hours to achieve the same using the manual tools. Needless to say that the difference may add up to a staggering number at the project level. So how does Visual Flow work? Visual Flow is based on Argo workflows, an open source container native workflow engine for orchestrating parallel jobs on Kubernetes. Argo workflows is implemented as a Kubernetes CRD. So first, users create jobs and pipelines in the UI. The jobs and pipelines are then stored as config maps and workflow templates in the Kubernetes namespace. Then users trigger pipelines manually or define run schedules. Then Visual Flow creates an instance of each workflow from a template. Argo launches each workflow in a separate pod. Spark jobs are executed as tasks in separate pods as well. And finally, Argo sends a notification to a Slack channel and/or email should any of the tasks fail. Since Visual Flow uses Spark to operate in data, it can support any type of data source that is supported by Spark itself. But the current UI's choice is limited to Amazon S3, IBM Cloud Object Storage, Elasticsearch, DB2, PostgreSQL, Oracle, MySQL, and others, with more data sources to be added in the future. Visual Flow specializes in Spark jobs creation and management and offers an easy-to-use IDE. One does not need a database to set up Visual Flow. All the configuration is stored in Kubernetes as config maps. All you need is a Kubernetes cluster. Visual Flow has built-in user role management wherein users can have one of the following roles. A super user can create projects and manage them. An admin can manage access within projects. An editor can create, delete, and modify jobs and pipelines. An operator can run and stop jobs and pipelines. A viewer can monitor execution of jobs and pipelines. Visual Flow supports user directories of GitHub and GitLab, as well as Open Authorization 2.0. Now, Visual Flow supports connection and parameter management to be leveraged by all jobs within a project to make sure global parameters are maintained in one place and one place only. It also comes in handy during a project migration. We support the so-called endpoints, data sources and targets, as well as simple arbitrary parameters that can be secured, such as passwords or plain text. As in most traditional ETL IDEs, in Visual Flow you design jobs by dragging boxes, aka stages, or processing nodes from the palette onto the job canvas and then connecting them together with arrows. Users can choose from one of the available stages: read, write, join, union, filter, group by, remove duplicates, transformer, change data capture, and so on. All of these stages but one are configured using a set of property fields. The transformer stage will require the use of Spark SQL and is intended for user-defined transformation logic, which is anything that is not covered by the other stages. Visual Flow supports job daisy chaining. A group of connected jobs is called a pipeline. Designing the pipelines is straightforward using drag-and-drop operations in Pipeline Designer, where you can also set up alerts. The alerts use Slack as well as email. An ETL job needs to be included in a pipeline so it can be scheduled in Visual Flow. Job and pipeline statuses can be monitored on the corresponding screens in the UI alongside the CPU and memory utilization. Just like the project parameters, the jobs and pipelines can be easily exported for code backups, migrations, and promotions. And now, let's see what it feels like to create your first ETL job in Visual Flow. For this exercise, we're going to build a simple ETL job using Visual Flow, which will use two source datasets. One is called sales and includes transaction ID, customer ID, year number, month number, and sales amount. The other includes customer ID and customer name. So what the job's going to do is it's going to filter the sales data set on year number equals 2022, and it's gonna join sales and customers on customer ID, and then it's gonna group the output by customer name, year number, month number, and it's gonna sum up the sales amount, and that's it. And it's gonna record the output into a Postgres database. When you first open Visual Flow, after selecting your project, which in our case is called Visual Flow Demo, it's going to get you to the overview page where you can see all your jobs and pipelines and the current resource utilization. All right. And then from there, the next thing you do is you navigate to settings. Here you can see parameters and connections. So the connections are your endpoints, is where you will be reading from and where you will be writing to. So you may want to specify those first. So all those parameters, right? And then you specify whatever parameters you might need here. Like we use access key, bucket name, etc., etc. All right. So once that is done, let's go to jobs. Let's hit add job. Okay. We call it hello world job. Give it a tag first job. From here, you can specify the execution resources, which for this exercise, I'm not doing. I just keep it at default and I save the job. Okay. So on the left-hand side, you can see our developers palette. Lots of connectors and transformations are here. So let's start with 2 read connectors for our customers and sales datasets. So give them names, read customers, specify the endpoint, which is AWS S3, specify the bucket, specify the path in the bucket, customers, CSV. The file format will be CSV. There will be a header and there will be a delimiter. Confirm. Okay, the next is read stage. Give it a name, read sales. Specify the endpoint. Again, the same Amazon endpoint, the bucket. All right, the path in the bucket. Sales, sales, CSV. The file format is going to be CSV again. We are going to use a header and there is a delimiter. Confirm. Then we're going to filter sales on sales year equals 2022. So filter sales year, and the filter is going to be year number equals 2022. Confirm. Then we connect those 2 stages. All right. Then we're going to rename the ID column in customers to customer ID to match the sales data set so we can join them. We use add update column stage for that. So we call it rename customer ID. The operation type is going to be rename column. The column is ID and the new column name is customer ID. Confirm. Then we just connect those stages. All right. So the next thing is join. Let's drag and drop it. Let's connect. Oh, oops. Let's connect the stages with the join stage. All right. Okay. Give it a name. Join sales customers. The join type is inner. The order is irrelevant, and the key is customer ID. Okay. We confirm. We save it. The next step, we need to discard the customer ID field because we do not need this. We also need to convert our sales amount because it has digit separators, which we don't need for a decimal field. So let's use the what's it called, select field that we use a transformer for that. All right. Right. So let's configure it. Let's give it a name. Select fields. Okay, so here's, you can see we list the fields we want to leave, and we also cast the sales amount field to decimal 10.2. Confirm. And then we aggregate. So we use the group by stage. Aggregate, group by customer, name, year, number, month, number. The aggregate function is going to be sum, and the column is sales amount. Confirm, save. Then we do one more rename, column rename. Okay. Rename sales amount. Operation type is rename column. The column is sum sales amount. We want to name it sum underscore sales underscore amount. We save it. And finally, we want to write the output to the PostgreSQL database. Okay. We just call it write Postgres. Choose the endpoint here. The schema name is sales. The table name is sum sales. The write mode is overwrite. The truncate mode is simple. Confirm. And that's it. Now let's just save and quickly review our stages just to make sure we haven't missed anything important. So I usually do some silly mistakes. Okay, this looks good. 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 And this is good. All right, so everything looks good so far. Let's just press run. And so far the status is pending. Once the job's running, there is a log. There's a logs icon up here, which we can press and watch live logs. Let's just wait a little bit for the icon to become active. Okay, it's active now. So the logs are appearing here as they are added. You can either press the refresh button here, or you can, it's just self-refreshing actually. And if there is an error message, you may want to stop the auto refresh by pressing the auto refresh button. Hopefully we won't get any of those and it'll just finish successfully. Let's just wait and see. It's going to take up to a minute, I think. Okay, that's it. The status says succeeded. That means we did a great job. All right, so now the last step is if we want to schedule our new job and we want to specify a notification, a success or failure notification, then we need to create a pipeline. So we navigate to pipelines, hit add pipeline, give it a name. Let's call it Hello World Pipeline. Yeah, give it a tag first, pipeline, like this. And for the notification, we specify email. We only want to receive failure notifications. to our email address. Confirm. We hit save. And we just add our job here. Okay. For the job, we specify the stage name. Hello world. I choose our job, which is hello world job. Okay, confirm. Confirm. Save. And that's it. Our job is now we hit the scheduler button here, and you can see you can switch it on, and you need to specify the scheduler configuration here in the format provided, like the minute, then the hour. Let's say we want to run it at 23 o'clock every day, every month, and every day of week. That's it. Once you have entered the values correctly, the save button becomes active. That's it. Now our job is scheduled, and we can even run the pipeline is scheduled, and we can run it on demand using the run button as well. And that concludes the job demo. And back to the slides now. To summarize everything said so far, Visual Flow helps you to kickstart your cloud ETL journey using an intuitive and concise user interface. It can run on any kind of Kubernetes cluster, in cloud or on premises, OKD, Red Hat, GKE, Google, EKS, Amazon, simple Kubernetes cluster, etc. It can be set up and ready to go in less than 30 minutes. It doesn't require knowledge of any programming, build, deployment, workflow, orchestration instruments. It helps to quickly design applications to move and transform large-scale, semi-structured datasets and load them into data lakes and data warehouses by combining the ease of use of traditional ETL tools and the power and flexibility of the Spark processing engine. While Visual Flow can be downloaded and used free of charge, IBA Group offers multiple Visual Flow related paid services such as product deployment, configuration, customization, ETL development, product support, and personnel training. Other data engineering services are also available on demand that include migration to cloud, ETL migration, data engineering and business intelligence, data science, data warehouse and data lake design, and Spark development. If you have any questions left after this session, or you would like to download Visual Flow or reach out to us to get you started on one of our data engineering offerings, please visit visual-flow.com. And thank you very much for your attention.